Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. I'm going to start by just copying out the question. Now the word solve means find out what x is, and the first thing we do when we see solve is draw lines to the left and right of our equal sign so we can solve it. So there's two things stopping us from having x on its own, this over 5 and this take away 10. Now that take away 10 isn't in the fraction, and normally I would say to get rid of the fractions first, but because that take away 10 is just sitting there on its own, we need to get rid of that first. So what I'm going to do is the opposite of take away 10 to both sides. So we're going to add 10 to both sides. That will leave the x over 5 on the left hand side, and 0 plus 10 is 10. So we want to get rid of this over 5, but what does over 5 mean? Well, it means divided by 5. So the opposite, the inverse of divided by 5 is times 5. So I'm going to do that to both sides. So we're left with x on the left hand side, 10 times 5 is 50. So x equals 50. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the center, that's a diameter. If you've got a line just going to the center, if I can draw it properly. Then that's called a radius. If you've got a line that touches the circle just on one point like that, that's a tangent. But in this case, we have a sector. So our sequence, our nth term, is 20 times n plus 6. For the fifth term, n would be 5. So it's 20 times 5 plus 6. 20 times 5 is 100. 100 plus 6 is 106. First thing I'm going to do to answer this question is I'm just going to quickly draw out the shape again, just so I can kind of show the calculations a bit easier. Okay, the first thing I'm going to do on the diagram is convert all of these lengths to centimetres. So we've got 4,200, 1,200, 2,400 and 1,800. And next I'm going to convert them into what the scale says they're going to be in our diagram. So a scale of 1 to 600 means 600 in real life, and this diagram is showing the real life situation, is 1 on our diagram. So I've converted them all in centimetres, and now I need to work out how many centimetres there are going to be on our diagram. So I'm going to start with the 4,200, and all you need to do is divide it by 600, and I get the answer of 7. So it's going to be 7 centimetres on our diagram. 1,200 divided by 600, it's going to be 2. So that's going to be 2 centimetres on our diagram. 2,400 is obviously going to be 4 centimetres. And 1,800, divide that by the 600, it's obviously going to be 3. So it's going to be 3 centimetres. So now we know what it's going to be on our diagram. We draw it. So we're going to do 7 across. So 1, 2, 3, 4, 5, 6, 7 across there. I'm going to do 2 down. So 1, 2, 4 across. 1, 2, 3, 4. I'm going to do the left hand one first, I think. So we're going to do 3 down here. And then we just kind of join it up with what's left over. And that's our diagram. So we're going to track the amount of eggs needed to make a certain amount of cupcakes. So we're given in the question that it's 6 cupcakes requires 4 eggs. And what we're going to do is we're just going to work out how many eggs is required for 1 cupcake. So we're going to divide both sides by 6. And that's for 1 cupcake will be 2/3 of an egg. And we're looking to make 18 cupcakes. So I'm going to times that by 18 on both sides. So for 18 cupcakes, 2/3 times 18 is going to be 12 eggs. So we're going to require 12 eggs. Something else we could have done to go straight there is just times the amount of cupcakes by 3 and times the amount of eggs by 3. Mode just means the most common or most frequent, and modal is exactly the same. It's just the most frequent amount of coins we're looking for. So the students who had 3 coins in their pockets came up 15 times. Students had 4 coins in their pocket, well there were 16 of them. There were 15 students who had 5 coins, 17 students who had 6 coins, and 12 students who had 7 coins. So the most frequent amount of coins a student has in their pocket will be 6, because it happens 17 times, which is more than any other amount of coins. All probabilities have to add up to 1. So what I'm going to do is I'm going to take away these probabilities away from 1. So we're going to do 1 take away 0.09 plus 0.13 plus 0.18. And so that's going to be 0.4. 1 take away 0.4 is 0.6. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3/2. Same with this one, 1 times the 3 at the bottom added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6s go into 15? Well, we're first of all going to have 2 whole ones. And how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape, so if we carry this on, it could be a nice U shape. It could also be a cubic graph as well, so it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're told that from 14 people who liked football, so we've got 14 people here who said yes, they do like football. So we can fill up the 14 here. Now, we're told we started with 31. Therefore, if 14 liked football, then 17 must have not liked it. Carrying on the sentence, it says 4 like rugby. So 4 of those liked rugby. And we had 14 to start off with, down this strand. And so that must mean that we've got 10 who don't like rugby. So of those 14, 4 liked rugby. So therefore 10 must have not liked rugby. But what about the bottom section? This part here, we've got 17 who didn't like football. Well, it says from the people who did not like football, 6 liked rugby. So we've got 6 there, and that must mean that we've got 11 who did not like rugby. So in this question, we're told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A, and we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares, and we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put a 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4, w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4, w to the power 5. Some people will try and do something with the v to the power 4, w to the power 5. But if you think about it, if I just draw out my square, if it's 11v to the power 4, w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same. So it'd be 15 minus x. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus x, the x, the 15 minus x, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus x and minus x, that's be a minus x. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know x is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we're going to be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.